Welcome to another introductory R and RStudio lecture. Today we're going to learn how to use R as a replacement for all your statistical tables. In general, there are four things that I need to be able to do with a statistical table. The first is I need to be able to calculate the height of a distribution curve. Whether it's continuous or discrete, I need to be able to calculate the height. This is going to be done from a function that I'm going to call a d function, and this calculates the distance from the x-axis to the curve. The next thing that I need to be able to do is to calculate the probability of some value and everything less than it. In a continuous distribution, this is going to be the area under the curve. In a discrete distribution, this is going to be the probability of some value plus the probability of everything less than it. So the p function gives the probabilities, but it's always the probability of that value or less. The other thing that I want to be able to do is the inverse of the p function, which is to say, if I know what the probability is that I want, being the probability to the left, what value in my distribution gives me that probability? So what value gives me 35% of my probability to the left and 65% to the right? This is just the inverse of the p function, so that we're going to call this my quantile function. And then finally, the last thing that I want to be able to do is to calculate a random sample from a distribution. Let's go see how to do this in R. So to calculate the distance from the x-axis to the curve, we're going to use a d function. And here we have a standard normal distribution. And let's say that I want to calculate the height of this curve, or the distance from the x-axis to the curve at x equals -1. Well, now what we're going to do is we're going to use a function called Dnorm. So the d stands for the distance from the x-axis to the curve, and the norm stands for the fact that I'm going to be doing this with the normal distribution. And so all of my functions are going to have this dpqr and then some suffix that denotes what distribution this is from. So the normal, with no other additions, will give me the standard normal distribution. And so this will give me this height of the curve, which is about 0.25. This function works similarly in a discrete case. Here we have the binomial distribution with n equals 10 trials and a probability of success for each trial of 40%. And I want to know what's the probability that out of 10 trials I get 3 successes. So I want to know this probability. And this, in the discrete case, represents the probability is the height of this observation right here. So that's going to be my d binomes. So that gives me my distance from the point to the x-axis. And in the discrete case, this corresponds to probability. So we're going to find out that this corresponds to a probability of 0.215 approximately in the binomial case with 10 samples and a probability of success of 0.4. The p function gives probability of a particular observation or everything to the left. In this case, we're going to again use our standard normal distribution, and I want to know what the probability is of having a result less than or equal to -1. And so this area is going to be about 0.15. So the Pnorm gives me the probability of less than or equal to -1. If I do 1 minus that, that'll give me area to the right, which will give me 0.84 approximately. In the discrete case, this does something very similar. The binomial of 3 will give me the probability of seeing 3, 2, 1, or 0. So the probability of 3 or fewer. And 1 minus that will give me the probability of 4 or more. In the discrete case, the less than or equal to the 3 or fewer actually matters, because in the discrete case, the 3 is included in the calculation. The 1 minus, that will not include the 3. Next, our inverse function the Q function says, well, if I'm interested in knowing what value along my x-axis gives me 25% to the left and 75% to the right, well, that's going to turn out to be negative 6, 7. But the way that I know this is using this Q function and saying, all right, I want to know the quantile, the 25th quantile of the normal distribution, of the standard normal distribution. And that is given at negative 0.6744898. And then finally, our R functions give us a way of calculating or of grabbing a random sample from a particular distribution. So R stands for the random deviates from a normal distribution. And here I'm going to grab 10,000 of them and then pipe them into my plotting function, which will give me a output graph or a histogram. And this looks pretty good. In general, you can ask for as few or as many random variables from a distribution. Here I'm going to ask for 5 observations from a normal distribution. So that's how you can use R to replace a whole variety of tables in the back of your statistics book. Your D, P, Q, and R functions work for a variety of distributions, whether it's T distributions, chi-squareds, F distributions. The only thing that you have to do is know the name of the distribution within R and what parameters you need to specify. So get rid of your tables in the back of your book and just use R because it's much, much easier. Have a great day, and I'll see you in the next video.